Goal 4 is to use the impulse formula to calculate the change in momentum. So the impulse formula is a couple things. So we know, if we look at the page before, we know impulse is force times time. We also know force times time is mass times the change in velocity. This is the change in momentum. So we'll kind of put both of those down. So impulse equals force times time, or force times time is the change in momentum, which is mass times change in velocity. Okay, so here if we're wanting to know what the impulse is, we're going to do force times time, but the force is 8 newtons and the time is 2.5 seconds. So 8 times 2.5 is 20 newton seconds. Okay, so if our impulse equals force times time, if my new impulse, just so you know, sometimes they'll use a J for this too, but if the new impulse, the force doubles and the time doubles, then this is the same thing as 2 times 2 times force times time. But we know that force times time is our original I, our original impulse. 2 times 2 is 4, so this is going to be 4 times greater. All right, a point guard runs down the basketball court. It runs into an opposing center with a force of 700 newtons for 0.9 seconds. So the impulse here is still force times time. The force is 700 newtons. The time is 0.9 seconds. So 700 times 0.9, and we get 630 newton seconds. For goal 5, we're going to be explaining how changing the time of the impulse changes the force of the impulse. Okay, so an impulse is really a change in momentum, which is equal to the product of force and time. So this is the equation I had put up here at the top, right? This is my impulse. It's a change in momentum, right? And, ooh, I wonder if they wanted, yeah, which is also the same thing as mass times a change of velocity, okay? So for this one, you know, if this is a multiple choice question, obviously it could be the product of mass and the change in velocity as well, okay? I think, though, looking at the examples, they're kind of looking for force and time still. All right, so a little boy is playing with his toy truck, and he hits the wall with an impulse of 250 newton seconds. And the time the truck is in contact with the wall is 0.2 seconds. So if the impulse is force times time, this is 250 newton seconds equals, I don't know the force, but the time is 0.2 seconds. So to solve for force, we're going to divide both sides by 0.2. So 250 divided by 0.2. The force then is going to be 1,250 newtons. All right, so the same little boy is playing with his truck, but his dad puts a padded mat on the wall. So what happens is the truck hits the wall with the same impulse, but now the time has increased to 1.5 seconds. So, same boy, still 250 newton seconds for the impulse, but now the time is a lot greater in comparison. It's 1.5 seconds. So we divide both sides. And now the force, oops, you know what? This guy right here, I missed a 0. This is 1,250 newtons. Okay, 1,250 newtons. Let's give some space here. Okay, so this one is 166.7 newtons. All right. So what I want to draw your attention to here is, notice the force here was 1,250. This force in comparison is a lot less. So we've talked about over and over, if you are increasing that time, right? If you're increasing the time for an impulse, then the force is going to decrease. Okay, so this goes to show same situation, impulse is the same, the time was increased, but the force decreases. If you run at the same velocity, the impulse of hitting a brick wall is equal to your impulse from hitting a padded wall. All right, so that change in velocity is the same. If the force you feel when you hit the padded wall is less, but the force you feel is less than hitting the wall. Explain, using the physics of impulse, why you feel less force when you run into the padded wall. Okay, so we're going to go back to this idea, okay? Running into padded wall increases the time of the impulse so the force will decrease and you will feel less when running into the padded wall. Okay, so by increasing the time of the impulse running into that padded wall versus the brick wall, it's increasing that time. It's going to decrease the force. All right, so that's a big, big idea.